नमस्कार मित्रों, उम्मीद है आप सब ठीक होंगे और इस सीरीज ऑफ वीडियो लेक्चर्स को एंजॉय कर रहे होंगे। अब तक हमने काफ़ी सारे वीडियोस रिफ्रैक्शन पर डिस्कस किए हैं वीडियो लेक्चर्स के सीरीज में। इन दिस न्यू लेक्चर I will tell you about refraction through this spherical surface. How do we draw the ray diagram for this spherical surface when the rays are incidenting on this, and we will establish a relation between refractive index, image distance, object distance, and radius of curvature of the spherical surface. Keep watching, keep learning.
So let us begin with this new lecture. In this lecture you will come to know about the concept of refraction through a spherical surface. For the purpose of convenience, I am taking here the convex surface as a spherical surface. This is the principal axis. Refractive index of this denser medium is mu2 and this rarer medium is mu1. On this principal axis, let us consider an object, point object. At this point P, we are taking two rays originated from this point O. One is passing along the principal axis, that will go straight, and let this is the center of curvature of this spherical surface. Then this would be normal to this, so this would be angle of incidence theta I. After getting refracted, this ray will bend towards the normal and travels in this way. So at this point these two rays are intersecting, so here the image is formed. Let this is the position I. And this point is taken as O. This angle would be angle of refraction theta r, and this is the refracted ray. Let this angle is denoted by angle 1, this angle by angle 2, and this angle by angle 3. These rays are P, Q and I. So if we follow Snell's law, then we can write mu21 is equal to sin theta I upon sin theta r. For small angles, mu2 upon mu1 would be theta I upon theta r. This we can write for small angles of incidence and angle of refraction. If we cross multiply, mu2 into theta r is equal to mu1 into theta I. This is the major relation we can have from this diagram. Now if we use the geometry of this diagram, then we can have this location at this point O, so that we can have triangles POQ, COQ and IOQ. If we use the property trigonometric ratios and the angle sum property here, then we can have the expressions for theta I and theta r. Our main aim is to find the expression for theta I and theta r. So if I take triangle PQC, then can I use the extra angle property? Yes. This angle theta I would be angle 1 plus angle 2, and in triangle PQC, theta I is equal to angle 1 plus angle 2, exterior angle property. And in triangle QCI, angle 2 is equal to theta r plus angle 3. So theta r is equal to angle 2 minus angle 3. Now we have to find out the expressions for angle 1, 2 and 3 by using the trigonometric ratio. So in triangle PQO or POQ, we can have tan 1 is equal to QO upon PO. From geometry of diagram, tan of angle 1 is equal to QO upon PO. Tan of angle 2 is again QO upon OC. And tan of angle 3 would be QO upon OI. Then, which implies angle 1 is equal to QO upon PO, angle 2 is equal to QO upon OC, and angle 3 is equal to QO upon OI. Then theta I is equal to 1 plus 2, so QO upon PO plus QO upon OC. This we have obtained from, let this is equation number 2 and this is equation number 3. So this we have obtained from equation number 2, and theta r is equal to 2 minus 3, so it will be QO upon OC minus QO upon OI. It is from equation number 3. Then equation first will turn to mu 2 into QO upon OC minus QO upon OI is equal to mu 1 into QO upon PO plus QO upon OC. If you open the bracket, mu2 1 upon OC minus 1 upon OI into QO is equal to mu O 1 upon PO plus 1 upon OC into QO. So QO to QO is cancelled. Then what do we have? Mu2 upon OC minus mu2 upon OI is equal to mu1 upon PO plus mu1 upon OC. If we reshuffle the terms, then mu2 minus mu1 upon OC is equal to mu2 upon OI plus mu1 upon PO. Now if we replace for the distances, you can see from the diagram this OC is equal to R radius of curvature, this OI is V, and this PO is U. This is object distance. If we use sign conventions also, then OC is equal to plus R, OI is equal to plus V, and PO is equal to minus U. Then mu2 minus mu1 upon R is equal to mu2 upon V minus mu1 upon U. So this is the relation between the radius of curvature, image distance, object distance, and refractive indices of the two media, that is rarer medium and denser medium, for the refraction at spherical surface. So in this lecture we discussed about the refraction at spherical surface only. The same we can follow for the concave spherical surface also, and we will get the same relation here, that will represent the image radius of curvature, image distance, object distance, and refractive indices of the two medium. I hope you learned the things in this video. Keep watching, keep learning.